Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so today we are going to start a new chapter. We have already ended the previous chapter. It was on pressure, atmospheric pressure, thrust, all related to those things. Today we are going to discuss about the next chapter, which is basically upthrust and Archimedes principle and flotation. Okay, so before we begin our discussion, so we will just briefly try to understand that pressure is being exerted by all fluids, isn't it? We have seen in the last chapter that atmosphere, it consists of gas, that is it is a fluid. Gas can be also regarded as fluid. So that fluid which is present all around the earth's surface do exert some kind of pressure on every object present on the surface of the earth. Now similarly, so what happens that due to this pressure we actually do not feel it, but this pressure has many impacts. We have discussed in previous chapters. In this chapter we are going to discuss what is the impact when some object is immersed in a fluid. Mainly we will be discussing regarding liquids, but we will be also giving a concept of the immersion in gases also. Okay, so what is basically upthrust? So I think you have all taken up your pen and copies. Okay, so write the heading of the chapter, upthrust. Okay, upthrust and Archimedes principle. Archimedes principle. Okay, so this is the name of our chapter. Okay. So I hope what is Archimedes principle, we will be slowly moving on to those concepts, but very first thing that we are going to discuss is about what is upthrust. Okay, so what is upthrust? You all have noticed that when you insert any solid object into a say bucket full of water, are you able to push that object very easily into the water? No. Very common experience, you take an empty mug and try to push it into a bucket containing water, you find it difficult to push that mug into the water, isn't it? So definitely what happens whenever, not only the mug, whenever you are trying to insert any object into a fluid, okay, there is a certain resistance or obstruction to that pushing, isn't it? Now that obstruction is actually due to the factor called upthrust. So basically what is upthrust? You have already learned about what is thrust. If we just briefly have a discussion, what is thrust, we can say in very short line, in very short concept, it's the upward force that is acting, upward force. Okay, upward force. So thrust means the force acting perpendicular on the surface, upthrust means the upward force acting perpendicular on the surface, that is the upthrust. Okay, now the upthrust basically what happens whenever we are trying to insert the object into the liquid, what happens, that liquid pushes that object, isn't it? You try to insert a mug into the bucket full of water and just remove your hands, what does happen? The water just pushes the mug up again, isn't it? So this is upthrust. So if we are trying to define upthrust, so how can you define upthrust? Very easy. You know what is upthrust? It is the force exerted perpendicular on a surface, isn't it? Force exerted perpendicular on a surface. So obviously upthrust will be something which is some force is acting upward. Okay, so basically it is the, you can say that upthrust is the upward force exerted by a fluid. That fluid can be liquid as well as gas, by a fluid, okay, on an object which is immersed into it, okay, immersed into it, fine, which is immersed into it. So that is basically upthrust. Okay, now very simple, very easy to understand. There is nothing very difficult in this concept. Simply just think of it practically. It will be easier for you to understand the concept of the upthrust. Okay. Now, can you just think of that this upthrust can be exerted on any object that you are trying to immerse in a liquid. Okay. There is another name for this upthrust. It is also called the buoyant force. It is also called the buoyant force. Okay. So this is the another name which is used simultaneously or synonymically with the word upthrust. Okay, buoyant force. Is that the same meaning as the upthrust? Okay, fine. Now, can you imagine that what are the conditions under which a body will float and under which a body will sink in a particular liquid? Can you just think of? Now, for this, you have to understand what are the forces acting on the body when it is immersed in a liquid. Now, just let us have a diagram. Let us just draw a diagram. It will be easier to explain. Okay. So I hope you have written this definition. If not, please pause the video and do write the definition. Okay. Writing is very important. Again and again I am telling, writing is very much important. Okay. Now say if there is a fluid, say water. Okay. And what are you trying? We are just trying to immerse an object. Okay, this is an object. Fine. Now, what happens when this object is put under the water? Two forces act on this object. What are those two forces? One force is that which is the weight of the body. It is acting vertically downward. Weight of the body acting vertically downward, mg. If the mass of the object is m, then obviously the weight of the object will be mass multiplied by the acceleration due to gravity, m into g. This is the force, gravity force. Okay, fine. And what is the other force? The other force is the upthrust. Okay, the upthrust, as we have already discussed, upthrust can be denoted with letter U. It is the upward force exerted by the fluid when the object is immersed into the liquid or the fluid. Fine. So these are the two forces. Now, whether the object will sink down or whether the object will float, should not that depend on these two forces, the value of these two forces, isn't it? Say, what will be the conditions when the object actually floats? Two conditions. Either you say that the upthrust is equal to the weight of the object. In that case, if the weight gets balanced, the object will float. And the second case is that if the upthrust is greater than the weight of the object, in that case also the object will float in the liquid. These are the two conditions. And what about the other condition? If we just see the other condition, third condition, if the weight is greater than upthrust, then obviously if the weight becomes greater than upthrust, the object will sink. So the first two conditions, these two conditions are for floating, the object floats, and this condition is for sinking, the object sinks into the fluid. Okay, so these are the very basic concepts that you need to remember. Okay, now if you just see these conditions or see these various conditions using diagram, what will be the diagram be like? Now, this diagram that you have drawn on the board, this is actually for the second figure. So if we just number it out, this is the first condition, this is the second condition, and this is the third condition. If we just draw it out, this figure will be for the second condition. So please note the diagram and draw the diagram and note it for which condition this figure will be. See, in this case, a part of the object is above the liquid. Okay, a part of the object is above the liquid. The liquid is up to here, and a part of the object remains above the liquid. This is the second condition. So this much part of the object remains above the liquid, isn't it? Yeah, this one part of the object remains above the liquid, and a part of the object immerses or just goes down below the surface of the liquid. So this is the diagram for the second condition. Now if you consider the first condition, when the weight and upthrust are equal, weight and upthrust are equal. In that case, what the diagram will be like? Okay, the forces will act in the same way. The forces will act in the same way, but the diagram will be a little bit different. What will be the difference? Let us see. So if we are just drawing the diagram for the first case, so this is the first case that you are drawing. If you have not drawn the diagram of the previous case, please pause the video and just draw the diagram. Okay. Now, in the second case, when the first case, when the upthrust and weight of the object are same, what will happen? The object will float, but the surface, upper surface of the object will be just below the liquid. Will be, or they say the surface of the liquid will be in same level as that of the upper surface of the object. You can actually see just the surface of the object on the liquid surface, isn't it? So this is the diagram for the first case, when the weight of the object and the upthrust are equal. Okay. Now moving on to the third case, what will the diagram for the third case be like? Now the diagram for the third case will be something like this. That okay, if we just redraw it, diagram for the third case will be something like this. Third case. Now here the weight is more than the upthrust, isn't it? Weight is more than the upthrust. Then what happens? In this case, the object will sink. Definitely it will sink, and what will happen? The object will be completely under the liquid. Here, if it is water, the object will be completely under the water. You cannot actually see any surface of the object. The object is totally immersed into water. This is the condition for the item for the third case, when the weight of the object is greater than the upthrust. So the upthrust cannot actually balance. Okay. What happens? The weight actually pulls down the object. The weight mg pulls down the object, and the upthrust actually is unable to balance the weight. So this is the diagram for the third case. Okay. So I hope the conditions for flotation or for sinking is clear. You can easily understand through these diagrams. I hope these diagrams are clear and the directions of force are also clear. Okay. Fine. So today we will be ending our class here. In the next lecture we will be just discussing what are the characteristics of this upthrust or the buoyant force, and what will be the value, or how can we determine the numerical value of the upthrust acting on a certain object when it is immersed in a certain fluid. Okay. So we will be doing that, discussing those topics in the next class. In today's class we will be ending it here. If you have any problem, any query, please do mention it in the comment box. We will be happy to solve your problem. And till the next class, please study well. Thank you. Goodbye.